Well, Section 5 isn't included in our official curriculum, but looking it over, I thought I would give you a review of it because there are some important items and strategies here. So we'll take a look at it. Expressions containing several radical terms. How do you treat them? Well, often you treat a radical as if it were a variable. That is, in like terms and in multiplication. And we have built a little bit up already, but let's take a look at this. So here are two radical expressions. Notice they have the same radical. Now here are a special relationship of radicals. We're going to FOIL them. And notice they are conjugates. That is, the same terms, opposite signs, and that's what we're going to be looking at as we go through. Okay, so let's go through some of the examples. Here we see that, again, they are like radicals. So what we do is we just add, in a sense, their numerical coefficient, a 6 and a 4. The radical part stays the same, and we get 10. Again, if this were like a 6a and a 4a, we'd get 10a. So we treat them a little bit like variables. In B, as we look at it, we have a radical 2, a radical 2, a radical 2 to the third root. So again, we just deal with the numerical coefficients. Here there's a 1. There's a negative 7. But notice now, this is a negative 7x. So the only radicals we can add together are the 1 and the 5 to make a 6. So theoretically we can put it like that, where they have all of the coefficients put together as factors, then they group it. Okay, that's an interesting one. So going on to C, again, some interesting things, and just to pick up on what they're illustrating. Here the index number is 5. Here the index number is 5. Here the index number is 3. So the only like terms we have are these. So we will then add those together and get 9, the fifth root of 4x, and then you have this, minus 3, or the third root of 4x. Now this next one is the one I illustrated in the previous tape, but let's take a look at it a little more carefully this time. So as we look to simplify this, we have 3, the square root of 8, minus 5, the square root of 2. And you might say, well, yeah, they're not like radicals, but notice we have said that this is actually the square root of 4 times the square root of 2. So the square root of 4 is 2. The square root of 2 minus 5, the square root of 2. So now this is going to become a 6, the square root of 2, minus 5, the square root of 2. And you had this simplification in the previous section. Now you end up with the square root of 2. And theoretically there's a 1 there, but we don't write it. Now for letter B, as we look down here, this is square root of 5, square root of 3. That cannot be simplified. So let me set this one up for you. I guess I left that running. Anyway, as you look at this, we want to divide this up into those that are perfect cubes and those that aren't. So we know we have a 2 over here, and x to the 6th is a perfect cube. Then we have y to the 3rd here, and this is a y. Now you notice that this part and this part are the same, but I deleted that. There are other parts that are not the same, so we'll look over here. And what we do is we put those other two parts together. Hit the wrong button. All right, we're now going to do some multiplication. And again, this is just a light review of dealing with more than one radical item at a time. So here, we'll use what is written here. We're going to distribute, and we get this. So this is x, the square root of 3, minus the square root of 15 as you join these together. In B, and I will write B out here. So there's to the first, there's to the third, so we're going to get the cube root of y to the third, which is a perfect third. And we get plus the third root of 2y. Now this will become just y, and then we write this, plus the third root of 2y. And that's what they have. Now we'll look at C in just a moment. Now when I did this the other day, I said there is a special way to square a binomial. We take this first term and square it and get 16. We then multiply these two terms together and get a negative for the square root of 7, and then double it, which will give us negative 8, the square root of 7. And then we square this, which is going to be a positive square root of 49, which is a positive 7. Well, we see we have like terms here. This becomes a 23 minus 8, the square root of 7, which is what they have here. Now, what they did is they did this as the traditional FOIL, which is your backup pattern, but they also illustrate what I showed you. Now, for this one, it's a little more tedious, and what you just do is the FOIL. So you're going to multiply this times this, and this gives you the square root of 9, which is 3. So you get 4 times 3 here, gives you a 12 for your first term. Now when you do your outers, this gives you a negative 5 times 4 is a negative 20. And then you have square root of 3, square root of 2 is the square root of 6. Now your inners would be plus the square root of 6. And we can put a 1 there, so you know you have to do some adding. And then when you do your last, we get the square root of 2 times the square root of 2 is the square root of 4, which is 2. Negative 5 times 2 is a negative 10. So we have a 12 and a negative 10 gives us a 2. And we have a negative 20 minus 1 gives us a negative 19, the square root of 6. And 2 minus 19 is square root of 6. Perfect. And I also did this one in the other tape too, where these are the conjugates. Okay, they're not mentioning the word here yet, but that's what they are. And when you FOIL conjugates, you only have to worry about the first and last. So this is square root of a times the square root of a is square root of a squared, which is a, minus the square root of b squared, which is b. And there's the work. Okay? And here they are introducing, finally, the word conjugates. It's a long time coming. And we need conjugates when we are going to rationalize denominators or numerators that have two terms. So let's do this one. Again, the work is all there. But it's 4 over the square root of 3 plus x. Now, to rationalize that, we have to multiply it by a 1. But the 1 that we choose will be the conjugate of our denominator if we are rationalizing denominators. So, same sign, or same term, but now opposite signs. And this is a 1. We're allowed to multiply anything by 1 without changing its value, and we choose the 1, in a sense here, to rationalize our denominator. So when we FOIL, this becomes the square root of 9, which is 3, and this becomes a negative x squared. And then my numerator, we just distribute 4, the square root of 3, minus 4x. And that's what they have. Now notice here your denominator was irrational. Here your denominator is rational. You have rationalized the denominator. Now here's one that's just a little more tedious. Let me set it up for you. So as we see this, again we want to multiply our denominator by its conjugate. So same terms, opposite signs. And this is a 1. So as we FOIL our denominator, square root of 5 times the square root of 5 is the square root of 25, which is just 5. This is going to be minus the square root of 4, which is 2. So our denominator here is just going to become a 3, which we see over there. So as we set it up, we multiply the denominator by its conjugate. Same terms, opposite sign. This is a 1. We got our 3 in our denominator. And then when we FOIL the top, we get this. Now notice there are no like terms in the top. So our top just stays the same. And it will be over 3. Okay? Now it looks a little tedious, but again, it's just following the basic rules we've been working with. Now when we multiply to rationalize the numerator, it's the same thing. We use the numerator, though, as our guide to what our conjugate would be. And then we multiply through. So our numerator then goes from being irrational to rational. And I'll keep this a little bit short if I can. Okay, this is something we haven't done recently. And it is a sort of division where your index number here is 4 and your index number here is 2. So what they're doing is they're converting it to their fractional exponential form, doing the subtraction, getting a result, and then converting it back to its radical form. We won't be doing that. Again, this section's not in our curriculum, but it's sort of interesting to do. Now, normally they have this included in section 2, but I see it here, it's in section 5. Let's just illustrate what's going on here. So here we're converting this radical expression to its exponential form, and this one as well. Now that we have it in this form, we can use the rule of exponents. To add these, we need a common denominator, and our common denominator between a 2 and a 3 is a 6. So I multiply this by 3, the 3 by 3, I get 9. Multiply the 3 by 2, the 1 by 2, I get 2. I add these together and I get x to the 11th 6. Now to put that back into radical form, I get the 6th root of x to the 11th. Now, can I simplify that a little bit? And they are doing that, actually. I can put that into one that is a perfect 6 and whatever's left over. Another technique we had. Well, this would be x to the 6th. This would be x to the 5th. Now, this is just going to be x, the 6th root of x to the 5th. And that's what they have here. And they've worked it out for you nicely here as well. Now in this next one, they're just showing you function notation, which they will say multiply the f function by the g function, which is what they have illustrated here. And again, since they are not with the same index number, we had to convert this one to its fractional form. And then as we multiply, we are actually adding. Okay? This is not raising a power to a power, it's multiplying radicals. So we just add the exponents. And when we finish, it looks like this. Again, we're not going to have one like this. And when we divide, as they are showing here, again, you're converting what you have to fractional exponents, and then do your multiplication, because now it's raising a power to a power, you multiply, and then doing your division and finally getting simplification. Again, we're not treating this, we're just showing this. That is a use of a skill we worked on earlier. All right, this will wrap up 7.5.